we're doing limit stuff, and it's pre-calculus, and calculus needs to be in radians. Make sure your mode is radians. Thank you. All right, then you just stuff it into your calculator. Easiest to do, trace, put graph with sine 1 over x, and then trace. Is it approaching 0.5? No, it's not. Okay, and it's not approaching it on the other side either. Oh, notice. It's just the opposite. The sine of x and sine of negative x are opposites. Here's a little cute thing. Zoom in, then reset x min to -1 and x max to 1. Zooming in should put y min and y max. You'll see a very strange kind of graph, and it is. It's a very strange graph. Okay, so graph the function. First, -x plus 1, but only between 0 and 1. So what you do is you imagine the function, and I'm going to draw it with a dotted line. There's the line y equals -x plus 1, but we're only drawing the part that's between 0 and 1, and we're including 0 and not including 1. Fine. And then the constant function 1 just between 1 and 2. Okay, and then at 2, let's see, what do we have? Equal sign at 1, no equal sign at 2. At 2, we just have a value of 2, so it's a dot up in the air. If you haven't graphed much in the way of piecewise functions, which I know you haven't, this is just sort of the way you do. Fortunately, you don't have to do many of them. X minus 1, let me do that in a blue dotted line. Positive 1 slope. Bing, 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 but again, only the part between 2 and 3, not including 2, but including 3. And then -x plus 5, so -3 plus 5 is 2, so it matches the height at 3. So 3 to 4. Okay, so, and it including at 4. Now notice I didn't have to put specifically a dot at 3. I'm gonna write little notes. Okay, so we did need a hole at 2, 1. Didn't need a special dot because it's just going right through. So limit as x approaches 0 from the right. Let me just draw that little bit. We're approaching 0 from the right. And what height are we approaching? 1. So this one is true. Okay. Does f of 1, which is here, equal the limit as x approaches 1 from the right? Yes, it is. Okay, does the limit as x approaches 2 from the right, so notice that's where the hole is, does that height equal 1? Yes. does the limit as x approaches 2, which is where the dot is, the hole, does it, if I approach it from the left and the right, am I approaching the same height? Yes. Okay, both sides approach a height of 1. Does the limit as x approaches 2 exist? Yes. So this one is true. Okay, so the next one, does the limit equal 2? No, this is false. Okay, does the limit as x approaches 2, which is 1, equal f of 2? This is 2. No. Okay, so the f of 2 is the dot. Okay. Does f of 2 equal 2? Yes. Okay. This is true. This is where the dot is. Does the limit as x approaches 1 exist? No. This is false because the left and right sides, the heights don't match. Okay, so if you look at it, on the left side, the height is approaching 0. On the right side, the height is approaching 1. They don't match up. Okay, does the limit as x approaches 3? Yes, that one's perfectly fine. As you go to 3, that is a perfectly good height. And the limit height is 3.
I mean 2. Oops.